Hi everyone, I am Sion Assam and this is my project, Sniffing Out Cancer, a behavioral chemotaxis of C. elegans to tumor-specific volatile organic compounds. Before I start, I would like to give a special thanks to Ircc for this wonderful opportunity. To give you some background, cancer is currently the second leading cause of death worldwide, second to cardiovascular diseases. And current screening tests of cancer have many limitations. Some are either very expensive, invasive, or not effective at detecting early stages of cancer. In the last couple of years, scientists have been able to discover that cancer patients release odorants, including volatile organic compounds through exhalation and urine. And a worm called C. elegans, thanks to their amazing olfactory system, can accurately detect cancer. So, the previous studies basically say that these worms are attracted to urine samples from cancer patients but do not respond to urine samples from healthy patients. So looking through these studies, I had one question in my mind. Do C. elegans show different behavioral patterns when exposed to metabolites of different cancers? And that eventually became my research question. My hypothesis coming into this experiment was that C. elegans will show different behavioral patterns because each cancer has a different signature of metabolites which have a different effect on the worm. The purpose of this study is to, one, determine if we can use C. elegans as an economical and fast method to detect cancer in its early stages, so we can give patients better suited treatment faster so they have a higher chance of survival. And to finally develop an app which will be able to diagnose if a person has cancer and what type the cancer is. So the variables of this experiment are: the independent variable are the metabolites from the two different cancers I'm comparing. The dependent variable are the behavioral patterns of the worm, and the control or the age of the worms or young adult, and the plate layout is the same, and the 60-minute time limit caps every experiment. And you can see in that table, those are the concentrations of the molecules I used. So the materials of the experiment are the C. elegans wild type culture, and to handle them, I used a worm pick, and to see them, I used a light microscope. And to grow the C. elegans culture, I grew them on an E. coli or B50 strain, which is a harmless strain of bacterial plates, and in nematode medium plates are where I conducted most of my experiments. So the methodology for this experiment is to basically conduct a normal chemotaxis assay. And basically what a chemotaxis assay revolves all around the plate layout. So the C represents control, or what the test solution is diluted in. And normally, in my case, that's water. And T is the test solution, and X is where the worms start out at the beginning of the experiment. So I placed the worms in the beginning of the experiment, set a timer for 60 minutes, and observed how the worms move. So what I most learned from this experiment is the life cycle of C. elegans and how to distinguish worms at each stage. And their whole life cycle goes in 3 days, and that's why it makes them one of the most perfect model organisms for researchers to use all around the world. So to start off my results, I compared the metabolitic specific response time, and you can see in the healthy, in the green lines, which represent healthy concentrations, the majority of the worms did not respond. While you can see in the orange lines, which represent cancerous concentrations, the worms did respond. And I went a little bit deeper and compared the average time and the population success rates of each molecule. And you can see colorectal cancer, or BHB, had a lower average time, but also had a lower population success rate. Then I wanted to calculate the chemotaxis indexes. Basically, the chemotaxis index is ranged from 1 to -1, showing if a worm is attracted or repelled to a specific molecule. And you can see acetone were at both ends of the spectrum, showing that acetone elicited a stronger response than BHB on the worms. So then I wanted to see what behavioral patterns the worms show as it traveled to the places. So I took a video of my experiment, put it into wonderful software called WormLab, where it spit out lots of data, and I was able to graph it, and graph it based on their averages. And you can see the averages are clearly different, but if you look closer, my data overlaps, showing that there's only subtle changes between these. So from the data collected from this study, I created an app which uses a classification algorithm to diagnose a patient on if they have cancer and what type the cancer is. And then from this app, I created a low-cost cancer screening system prototype where a camera is recording one of my experiments, and then the video is sent to WormLab, where the data from WormLab goes to my app, sniffing out cancer, and then you can print out the diagnosis or save it forever in your records. Even though my study had a lot of limitations, like the low number of samples, I concluded that this was a proof of concept study that shows that C. elegans can detect and react differently to different metabolites from different cancers. And worms in the near future can be able to use as a cheap, non-invasive way to screen for cancer and maybe even help out figure out what kind of type it is. These are my references, and thank you for listening.
If you want us to prove this study, how would you repeat it?
If I want to prove this study, I would increase the sample size, because I'm only using one worm per trial right now, and researchers in actual universities have like 20 to 30 worms in one plate, and seeing how a population moves instead of just one worm can prove a lot more.
Thank you.
What was the reason why only one worm was put in the plate at one time?
The reason why only one worm was put into the plate at one time is because it's hard for me to control two types of worms. And one of the biggest challenges for me in this study was to place the worms into the test plate without killing it. So more than one worm would be harder for me to handle and see.
Why did you choose these two specific forms of the cancer?
So I chose acetone and colorectal cancer because their main metabolites for lung cancer, that would be acetone, and for colorectal cancer, that would be beta-hydroxybutyrate. They were easy for me to access, and I could use it safely.
But is it known that these are excreted to the urine from these patients?
Yes, and at the specific concentrations.
Thank you.
Thank you.